Hi, welcome to Lesson 18, Session 2. We're going to be continuing our work with fractions as division. We have been kind of exploring how all the really cool things that we can do and the relationship between division, between fractions and division. And we're going to keep exploring that over the next 2 days. So let's go ahead. Today we're going to be working in our Ready Classroom Math Workbook, page 379 through 384. So if you're ready, which you are, you know it, go ahead and turn to page 379 in your Ready Classroom Math Workbook. On this page, this is the problem we have. It says, Jared, Monica, and Heather have 5 hallways to decorate for the student council. If they share the work equally, how much will each student decorate? So first of all, we're talking about decorating a hallway, decorating for the student council. And what we're trying to find out is if they share the work equally, how much will each student decorate? And the important question here is that we have 5 hallways that need to be decorated, and then they don't give us the number, the other number. However, they tell us this hint here. They tell us that Jared, Monica, and Heather will decorate the 5 hallways. So what that means is we have how many people? 1, 2, 3 people. So we have 3 people who are going to decorate 5 hallways. So we need to think about it. What is it that we're dividing up in work? So what we're dividing up is we have 5 hallways, and we're dividing that up. So, oops, sorry guys. We have 5 hallways that we're trying to divide up between 3 people to decorate them. So we want to know what are 5 hallways divided by 3 people. So based off of our lesson yesterday, you probably already know the answer, but I want to draw a picture just to give you an idea. So what I'm going to do is I'm going to draw 5 hallways. 1, 2, 3, 4, 5. So I'm going to draw 5 hallways. Then I'm going to divide each hallway up into 3 parts because we have 3 people who are going to be decorating a part of each hall. So we have Jared. Jared's going to be green. So Jared is going to decorate a third of this hallway, 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 and a third of this hallway. And then we have Monica, who's going to do this hallway, this part, this part, this part, and this part. And then we have Heather, who's going to do each of these parts. Now, we only want to know how much each student, like if one student had to do their part, how much would they decorate? So if we're Jared, he decorates, how much of this whole does he decorate? That's right, he decorates 1/3. And then he decorates 1/3 of this hallway, 1/3 of this hallway, 1/3 of this hallway, and 1/3 of this hallway. If we added all of these thirds together, how many would we get? You guessed it, we would get 5 thirds. So the way that we got there, remember, 5 divided by 3 equals 5 divided by 3. But this is what it looks like in a picture. We have 5 hallways. Each hallway is divided into 3 sections, and then one person's section is the result or the quotient. Now remember, we can turn this improper fraction into a mixed number. 5/3 is the same as 3/3 plus 2/3 because we keep the denominator the same, and then 5 has one whole group and then 2 parts left over. So the total answer is each student will decorate 1 and 2/3 hallways. Let's see if we're right. Okay, I know we're right, but we're just going to keep going. All right, so here, this is similar to what I did on the last page. We drew the 5 hallways. We split each of the hallways into 3 sections, and each Jared, Monica, and Heather were all given a separate color. And then we looked, and they decorated 1/3 of each hallway. Then we could add up all of the reds, for example, or all of the blues, or all of the greens, and we would find out how much each student did separately. If you wanted to, so this is using a fraction model to picture how the students would divide up the work. Now, in the model it section, you can also use a number line to show how much, to model each student's share of the work. So they took the number line, they wrote the number line from 0 to 5, and then they put in 1, 2, 3, and 4, and then they broke each group of each whole up into 3 parts. And then they filled in 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, and so on and so forth. Then what they're showing you here is you could take all of Jared's thirds and basically pull them out and put them all together on the number line, and then Monica's thirds and pull them out and put them onto the number line, and then Heather's thirds and pull them out and put them onto the number line. So while it looks a little bit different, each student is still doing 5/3 or 1 2/3 of a hallway. So number 1 says, how many thirds of a hallway are there to decorate in the 5 hallways? So that means in the 5, they want to know, so each one of these squares is 1/3. How many thirds do we have all together? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 15 thirds. We also could have multiplied the 5 hallways times the 3 groups. 3 times 5 is 15. Number 2 says, how many, maybe, we'll see what it, all right, how many thirds of a hallway will each student decorate? So let's just count Jared's thirds. His are red. How many thirds will he decorate? 1, 2, 3, 4, 5. He will decorate 5 thirds. Now we're going to write that as a fraction. How would we write 5 thirds as a fraction? That's right. We would just say 5 thirds. Now remember, 5 thirds is an improper fraction, which I'm assuming we'll get to at some point. Write a division equation that shows the quotient as a fraction. So remember, what does this bar mean in the middle? It means divided by. So what expression or what equation could we write? Well, 5 hallways divided by 3 people equals 5 thirds. Write a multiplication equation to check this equation. So if we said, all right, let's say 3 times 5 thirds equals, now 3 times 5 thirds, that would be the same as 3, we haven't learned this yet, but I'm going to show you just because it's a little precursor. 3 can also be written as 3 as 1. And then when you multiply fractions, you just multiply straight across. So 3 times 5 is 15. And then 1 times 3 is 3. 15 thirds is the same as 15 divided by 3, which equals 5. So that's how you can check your work. Now, looking back at this 5 thirds, how many whole hallways can each student decorate? Remember, 5 thirds is the same as 3 thirds plus 2 thirds. So how many whole hallways can they decorate? That's right. They're each going to decorate 1 whole hallway. And then how many hallways will not be done after that. Those are done. Well, if each person, so let's pretend each of these, or we know each of these is a hallway. So if Jared does this whole hallway, and Monica does this whole hallway, and then Heather does this whole hallway, how many hallways are left? That's right. 2 hallways are left to be done after that. Now, if we look at these 2 hallways, how much of the remaining hallways will each student need to decorate? So it's still split up for us. So how many, if we're looking at Jared's red, how many thirds left does Jared need to paint? Yeah, that's right. 2/3 of a hallway. So what is our mixed number to show how many hallways each student will decorate? Well, we already know because we did it on the very first page and we also wrote it here. They're going to decorate 1 2/3 of a hallway. So now we're going to calculate this remainder. So this is going to be kind of weird. So 5 divided by 3, we know that we have 1 hallway. And then because 3 goes into 5 one time, but then there's some that are left over. How many are left over? That's right, there's 2 parts left over. So now we're going to compare how this answer here relates back to here. So the whole number is the same. We have a 1 in both the mixed number answer and the answer here. The remainder is the same as the numerator. So the 2 here is the same as the 2 in the numerator. That's interesting. So number 6 says, how does the bar in a fraction represent division? So it's talking about this bar in the middle right here. What does that bar mean? The bar means that the number in the numerator is divided by the number in the denominator. So when we have a fraction like 2/3, 2 divided by 3 is what that fraction represents. So now what strategy do you like best for finding fraction quotients? So the two strategies that we've looked at here are using a fraction model or using a number line. So I want you to tell me the strategy you like best and why. When you're done, you're going to go ahead, you can pause it and fill that out. And then when you're done, you can go to page 382, and we've got a few problems to do on our own. So number 8 says this. 5 friends are equally sharing 3 packs of football cards. How many packs of cards will each friend get? Use a visual model to support your answer. So we have to decide, what are we dividing up? Now, I'm going to tell you a little secret. We are not going to divide up people, okay? There's only a few times when you're going to divide up people. But if we had 5 people and we divided them into 3, could you take 5 people and make them 3? No, you definitely couldn't. So you're not going to divide up people. That would be gross because you would have to tear them apart. So we're going to go ahead and think about what is it that we're splitting up in this problem. And in this problem, we're splitting up 3 packs of football cards. So let's go ahead and make our 3 packs of football cards. Now, how many people are sharing these 3 packs of football cards? 5. So we're going to make each of these into fifths. And then we're going to color in 1 of each of those packs because we're trying to figure out how much each friend is going to get. So we start out with 3 packs of cards. We divide them by 5 because 5 people are getting them. How many are they each going to get? 3/5 because 1/5 plus 1/5 plus 1/5 equals 3/5. 1/5 plus 1/5 plus 1/5 equals 3/5, or 3 divided by 5 equals 3 divided by 5, or 3/5. Now we're going to look at number 9. Number 9 says this: Elena made 10 ounces of apple chips. She put the same amount of apple chips into each of 4 containers. How many ounces of apple chips are in one container? Write a division expression to represent the problem and solve. Write the solution in remainder form and as a mixed number. Use a visual model to support your answer. So I'm going to go ahead and first we're going to look at, okay, what is this question talking about? This is like a big question. So this question is talking about apple chips that are being divided up into different containers. Now, what is it that we're trying to solve? There are multiple things we are doing here. Ultimately, we want to find out how many ounces of apple chips are in one container. But we need to write a division expression to represent the problem. We need to write the solution in remainder form and as a mixed number. And then we also need to use a visual, which I've actually already put here to begin with. And then what is the important information in this text? Well, the important information is that we have 10 ounces of apple chips and that we're going to divide it into 4 containers. So let's begin with writing a division expression to represent the problem and solve. So we have 10 ounces of apple chips. We're going to divide those 10 ounces of apple chips into 4 containers. So our answer is 10 divided by 4. Now remember that this is an improper fraction and we want to write the solution in remainder form and as a mixed number. So the first thing that we want to do is we want to look at this and go, okay, how many times does 4 go into 10? Well, 4 goes into 10 2 times because 2 times 4 is 8. And then we have 10, so that means that we have 2 left over. So this equals 2 remainder 2, because we have 2 wholes, so we have 10 has 2 groups of 4, which is 8, and then 10 minus 8 is 2, and that's our remainder is 2. We can also write 10 fourths as a mixed number because that equals 4 fourths plus 4 fourths plus 2 fourths. Remember, when we're adding fractions, our denominator stays the same, and our numerator, and we add the numerators. So if our denominator stays the same, we have 4 plus 4 plus 2 equals 10. So this is 1 whole, another whole, and then 2 fourths left over. So we have 2 and 2 fourths, which is actually also equal to 2 and a half. So now we've written the division expression and solved it. We wrote the solution in remainder form. This is remainder form, and then as a mixed number. So we did that. Now we need to use a visual model to support our answer. So to do this, the way that I'm going to do it is that I have started with 10 ounces. So we have 10 ounces of apple chips. And we're going to take each of these ounces and equally put each ounce into 4 containers. So I'm going to give each of these 4 containers their own color. So I've got a blue, a pink, a green, and an orange. So the first thing I'm going to do is divvy up until as long as I can give I have enough to give everyone a full ounce. So here I can give the blue a full ounce, the pink a full ounce, the green a full ounce, and then the orange a full ounce. So now I've given each container 1 ounce of apple chips. And as long as I have more than 4 left, I can keep going at this same rate. So now I'm going to give the blue another full ounce. I'm going to give the pink another full ounce of apple chips. The green, another full ounce of apple chips, and then the orange, another full ounce of apple chips. So now each container has how many ounces of apple chips? That's right, 2. If we were just counting the blue, we have 1 ounce, 2 ounces of apple chips. So that is our 2 holes. Now, we don't have four holes left to give another ounce to each container. So now we're going to have to break up each of these remaining 2 ounces into smaller parts. So I'm going to break each ounce up into 4 parts. So blue gets 1/4. Pink gets 1/4 of this ounce. Green gets 1/4, and then orange gets 1/4. And then I'm going to do the same thing again for the last ounce. 1 ounce, 1 ounce. I mean 1/4 of an ounce, 1/4 of an ounce, 1/4 of an ounce, and then 1/4 of an ounce. So now when I go through and I'm going to go a little bit closer so you can see. So now when I go through, I can see if I'm just going to count how much goes in one container, I'm only going to count blue. So blue has 1 ounce and 1 ounce. So 2 full ounces, that's our 2 and our whole number. And then each of these ounces are broken into fourths. So each little tick mark is 1/4. So how many blue fourths do I have in these remaining 2 ounces? I have 2 remaining fourths. So that is where my 2 and 2/4 comes from. So each container has 2 and 2/4 of an ounce. Yikes. So this here might have felt a little bit difficult for you, but don't worry about it. This is not an easy thing to do. And in fact, the first time I did it, I made a mistake, which is why I had to refilm this part of the video. So don't worry about making mistakes. So now the question here says, does the remainder form or the mixed number form best answer the question? Explain. So we have remainder. The remainder form here is 2 remainder 2, and the mixed number form is 2 and 2/4. In your opinion, which of those answers best explains how many ounces of apple chips go in each container? Go ahead and say the form that's best is. Tell me the form and then tell me why. Go ahead and do that now. And then when you're done, we're going to go to number 10. Now for number 10, we want to know which expression is equivalent to 12/7. So remember that that bar in the middle of 12/7 means divided by. So which of these 4 expressions is equivalent or equal to 12/7? Go ahead and choose your answer now. Okay, remember this with if this means divided by, you start in the numerator and you say 12 divided by 7. Which of these examples says 12 divided by 7? That's right, C. This expression shows 12 divided by 7. 12 divided by 7. With that, you're going to go ahead and do pages 383 and 384 on your own. As always, if you have any questions, you can always email your teacher. See you next time.